Okay, guys, welcome back to Lesson 2, Unit 5. We're going to be, the main theme today is, of course, sticking with polynomials. We're going to learn what linear factors are and zeros. Zeros are pretty much just where a parabola, or I shouldn't say parabola, where a graph would cross the x-axis if you were to graph it. But we're going to focus on factoring today. So remember the steps to factor completely. We always look out for GCF first. Then we look if it's a trinomial or binomial. If it's a trinomial, we got to follow our sign rules. Whether it's plus, plus, minus, minus, or plus, minus. So you'll see me review those today. If it's a binomial, it may be a difference of squares. If it is, remember the signs for that are plus, minus. All right, so example 1, we're going to factor completely. So we may have more than one way of factoring in this problem. Please pause periodically, rewind as much as you need, because I'm going to talk a little fast here today. So in the first one, there is a GCF of x. So then we divide by x to have a leftover x squared plus 7x plus 10. Then, from there, inside the parentheses, we have a trinomial. Can I think of two factors that multiply to get 10 that add up to 7? Yes, I can. 2 and 10. So x plus 2. I meant to say 2 and 5. 2 and 5. And then there it is, factored completely. So in these problems, we may end up having to factor more than once. Letter B, there is a GCF here of x. Divide by x to have x squared minus 7x minus 18. I do have a trinomial left over, so I'm going to try to factor that. Remember, we always look at our C term first. Notice it's a minus, so that means my signs are plus minus. And I need to think of two numbers that multiply to 18 and subtract to negative 7. Those would be 2 and 9. Remember, the rule is the sign of b goes to the bigger number. So the sign of b is a negative. It goes to the bigger number 9. So minus 9 and plus 2. Letter C. Do we have a GCF? Yes, we do again, another x. Then divide by x to have x squared. We have another trinomial left over. The C is a minus, so my signs will be plus minus. Can we think of two numbers that multiply to 21 and subtract to get negative 4? Yes, we can. 3 and 7. The sign of B goes to the bigger number. So x minus 7, therefore x plus 3. All right, 3 down. Let's keep rolling. Letter D, we have a GCF of x. Again, it's common to both. And then divide by x to have x squared minus 36. Remember, this is a binomial, x squared minus a square rootable number. That's what we call a difference of squares. Bring down your x. Guys, please make sure when you have a GCF to drag it down to your answer. Okay, so now, remember the signs for difference of squares are always plus minus, and then you square root the 36. Remember, 36 is a perfect square. You can square root it. Letter E. Not only is the GCF an x, it's actually a negative x. Please remember that when we have the first term being a negative, we must GCF a negative, factor out a negative. So then carefully divide by negative x, which will change the signs of the original terms. Okay, now we have a trinomial that can be further factored. Two signs are easy, plus plus. Two numbers that multiply to get 16 add up to 8. Easy. They are 4 and 4. All right. GCF here is x. Not only x, it's actually 3x. 3 goes into 9, 6, and 3. And then divide by 3x. Sometimes what I suggest people do is give themselves a little bit of space down here. So then they can, it's a nice visual sometimes to show the dividing fraction. So you can, it actually goes a lot easier on your eyes and your brain when you see it up here. So you can easily see, okay, that's going to be 3x to the second plus 2x minus 1. And let's see if I can factor this further. This might be a, it looks like a hard trinomial because the 3 in front of the x squared. Let me use the guess and check method. It may factor, it might not. So outside would be negative 3x. Oh, that should be 1. And then that would be plus 1x. That adds up to negative 2x. Let's switch the signs. Oop, that was not meant to happen. Alright, gonna test it. The check outside, inside, and that adds up to 2x, so that means my factoring's correct. So I did end up factoring a hard trinomial here. I believe I taught you guys the 8 times C method. I did the guess and check method here, though. Okay, letter G actually is a difference of squares. We normally see x to the second minus 16, but x to the fourth is an even-numbered exponent, which means that can also be a difference of squares. Of squares. So instead of x's in each of them, x to the fourth breaks up into x squared in each of them. And of course, difference of squares has plus minus, and then the square root of 16 gets the 4s. Now, we can actually go further if we look carefully here. The first one, x squared plus 4, is not a difference of squares because it doesn't have a minus sign. The second one that I underlined is actually a difference of squares. So I can factor that further, of course, into x plus 2, x minus 2. Guys, if you don't remember stuff like difference of squares or trinomial signs or anything that I'm going over today, if you're lost, please make sure to pause this video, go into YouTube, and type in whatever you need a refresher on. Okay, this problem's done here. Letter H is actually called a trinomial to a higher degree. So this is new for today. We are going to treat this very similar to this guy here. Okay? Except that instead of having x and x in the parentheses, the x to the fourth splits up into x squared and x squared. So the sign rules, we're going to ignore this. The b is actually a minus. So the c is a plus 6, the b is a minus, so that means my signs have to be minus, minus. And then two numbers that multiply to get 6 add up to 7 are 1 and 6. Now, can I factor further my first parentheses? Yes, I can. That's a difference of squares. So x plus 1, x minus 1. Can the x squared minus 6 be factored further? No. 6 is not a square rootable number. So that is not a difference of squares. Just bring it down, and there's your answer. Letter I. There's a GCF first. It would be negative, because it starts with a negative. And then your first term, or actually 3 does go into 78 and 75. so it would be negative 3. If you're ever unsure, what you would do is just, in a calculator, 78 divided by 3. If you get a whole number, you're good. 75 divided by 3. If you get a whole number, you're good. Me, I'm pretty good at the mental math, so I know they go into those numbers. Actually, it's negative 3x. X is common to all of them, as you can see here. And then I'm going to carefully divide by negative 3x. So that'll give me 1x to the 4th minus 78 over 13 is 6. Nope, that's not right. 26. Minus 26x to the 2nd, and then plus 25. Let's bring this down. I have a trinomial to a higher degree, so I'm going to split that into two binomials. X to the 4th is x squared in both. My signs. C is a plus, so that means they're both the same. They're both minus, minus. Two numbers that multiply to get 25 add up to 26 are 1 and 25. Now I can actually factor more. I get a difference of squares here and a difference of squares here. So I have a lot of factoring in this problem. Bring down my GCF. The first one is x plus 1, x minus 1. And then the second, x plus 5, x minus 5. So we ended up having 5 factors here. Okay, letter J. There's no GCF, so this is a trinomial to a higher degree. So x to the 4th splits up into x squared in both. The signs here are minus, minus. Again, if you are a little shaky on your sign rules, are you done? Okay, just go play. All right, I apologize, guys. My kid walked in. All right, sign rules are minus, minus. If you guys are ever shaky on your sign rules, remember to Google up trinomial sign rules. You have to commit those to memory. It is very important. It's no longer acceptable to screw up sign rules. Okay, so two numbers that multiply to 9 and add up to 10 are 1 and 9. And then we have a difference of squares here for both of them. Both are difference of squares. So the first one is x plus 1, x minus 1. The second one is x plus 3, x minus 3. Letter K, GCF, I'm looking for right now. Yes, 4 goes into 4, 2024. And T is common to all of them. And notice I'm going to do T to the 2nd, the smallest T. So then I got to divide to see what's left over in parentheses. So divide 1t to the 4th minus 5t to the 2nd plus 6. So in that trinomial, I have in those parentheses, I have a trinomial to a higher degree. So let me bring down my GCF, and I'm going to go into two binomials. The t to the 4th gets split up as t squareds. Sign rules are minus, minus. Be careful here, two numbers that multiply to 6 and add up to 5. You should have 2 and 3. Now, can I factor further? Nope. This guy is not a difference of squares. This guy's not a difference of squares because there's no perfect square. So these are finished. Do I have a GCF here? 20 goes into 100, but not 125. I'm thinking 5 is the GCF. And the X is, yep, common to all of them. So go with the smallest x squared. And then we're going to divide by x squared. 5x squared. So that'll be 4x to the second minus 20x plus 25. Bring down your GCF, because I can definitely factor more here. And this would be a hard trinomial. It's actually what's known as a perfect square trinomial. Notice something, this never came up in class before, but when you have the first and last numbers square rootable, there's a major shortcut that works. It doesn't work all the time, but it works 90% of the time. It would be the square root of 4x squared is 2x. The square root of 25 is 5. And the minus. The normal sign rules, of course, apply here. Minus. You guys may want to ask, may be thinking like, whoa, what about the minus 20? Well, if you do the outside, multiply the outsides, and multiply the outsides here, and then add them, what do they get? They get that minus 20x. But I just taught you guys a little bit of a shortcut. It's not really formal. That's why I haven't taught it before in class. All right, that's done. Letter M. GCF, 3, 2, 8, nothing there. The x's are common. Let's go with an x to the second. And then divide by x to the second. To have 3x to the sixth minus 2x to the third minus 8. This is actually the beginning of the problem's not challenging, but after that, this problem is extremely challenging. We have, believe it or not, a trinomial to a higher degree. You know, we're used to, say, x squared plus bx plus c. There's also what we saw today, x to the fourth plus bx to the second plus c. And there's also this one, which is x to the sixth plus bx to the third plus c. They're all done relatively the same. The x to the sixth just gets split up into x to the third in each of them. So it's something brand new to today's class. Now, the sign rules, of course, got to be plus minus here. I'm going to use the guess and check method. My A term is 3, so that can be split up as 3 and invisible 1. And then I can try to guess with factors of 8. So 1, 8, and 2 and 4. So I'm going to try 2 and 4 first. So if I check, multiply the outsides, and then multiply the insides, and they add up to negative 10. So that doesn't work. I need them to add up to negative 2. This might not be factorable, actually. Let me switch up the two numbers. Let me put a plus 4 and a minus 2. So the outsides would be negative 6. The insides would be plus 4. They add up to negative 2, which is my B term here. So my guess worked out after I checked it. Again, if you're a little confused by what I just did there, type in factoring trinomials guess and check method. So there it is. It's now completely factored. N, no GCF here. This is a difference of squares to a higher degree. So let's do our two parentheses with our plus minus. And remember, perfect squares we square root. Or difference of squares we square root. So 16x to the fourth would be 4x to the second in both. Remember, we're square rooting the number in front. We're technically dividing the exponents by 2. Then the square root of 81 is 9. So we started off this problem with difference of squares. Can we factor more? This guy, the first one, no. But the second one is difference of squares. Again. So that'll be, notice they're square rootable. 4x to the second would be 2x in both. Square root of 9 would be 3 in both. And of course, my signs are plus minus. And then your first guy, you just bring down. It was not factorable anymore. Okay, this is a super long lesson. I'm actually going to stop here, and then we'll continue on tomorrow in the part 2 of this. And then the day after that will be the homework. So it'll be 2 lessons, then the homework. Little change up from usual.